Well students, topic of the video is binomial theorem. This is our fourth lecture on this topic. Seventh term is find the term independent of x of the expansion of this one. Independent of x means power of x is equals to 0. Let r plus 1th term be the required term. Therefore, t of r plus 1 is equals to 9cr 2x whole to the power 9 minus r 1 by 3x square whole to the power r. So 9cr 2 to the power 9 minus r x to the power 9 minus r 1 to the power r is 1 3 to the power r x square whole to the power r is x to the power 2r. So 9cr into 2 to the power 9 minus r x to the power 9 minus r minus 2r. So x to the power 9 minus 3r minus r minus 2r minus 3r by 3 to the power r. According to the problem, 9 minus 3r equal to 0. So 9 equals to 3r. So r equals to 3. Therefore, required term is 9c3 into 2 to the power 9 minus 3 into x to the power 9 minus 3 into 3 by 3 to the power 3. 9c3 is 9 into 8 into 7 by 6 into 2 to the power 9 minus 3 is 2 to the power 6 x to the power 0 by 3 to the power 3. This is our required answer. And the next sum is next 8. Prove that the middle term in the expansion of x plus 1 whole to the power 2n is this one. Here power of the expansion is even term. 2n is even. Here n is an integer, so 2n is even. Therefore, middle term or mid term equals to t of 2n by 2 plus 1, t of n plus 1. So t of n plus 1 is 2n cn x to the power 2n minus n into 1 to the power n. 2n cn is 2n factorial by 2n minus n factorial into n factorial into x to the power 2n minus n is n and 1 to the power n. So 2n factorial by n factorial into n factorial. 1 to the power 1 is x to the power n. So 2n factorial can be written as 2n minus 1, 2n minus 2, 2n minus 3 dot dot 5 into 4 into 3 into 2 into 1 by n factorial into n factorial into x to the power n. So this is an even number, this is even number, this is an even number, this is an even number. Now there exists in the factorial of 10, there is a 10 term. In the factorial of 11, there exists 11 terms. The factorial of 12, there exists 12 terms. So factorial of 2n, there exists 2n number of terms. Out of 2n, n is even number and n is odd number. So from the all even numbers, if we take 2 common, so there is 2, there is 2, there is 2, there is 2. So if we write even numbers together, then 2n minus 2 dot dot 4 into 2, and the rest of the number, that is odd numbers, we cannot take 2 common from this, is 2n minus 1 up to 5 into 3 into 1. So by n factorial into n factorial into x to the power n. So if we take, if there exist n number of terms, so n number of 2 is common from here, so 2 to the power n, within bracket n minus 1 dot dot 2 into 1 into 1 3 5 dot dot 2n minus 1, and in the denominator part, this is x to the power n. Now these n factorial can be written as n into n minus 1 dot dot 2 into 1 into n factorial. By cancellation these two, so we get 2 to the power 1 into 3 into 5 dot dot 2n minus 1 by n factorial into 2 to the power n into x to the power n. Proved. This is very important sum. In the next video on this topic, we discuss few more sums on binomial theorem.